Okay. Guess we're ready to get going now. So let's see. We're starting here. Example A. This is the same example that we've been working through, finding the whole, the asymptotes, intercepts, and everything. So now we are going to look at the graph itself and figure out how to determine domain and range from the graph. And then we'll also talk about how to find domain and range without looking at the graph. So starting with domain, and just to define domain, the domain is the whole set of x values that exist within a function. So if we look at any kind of function that we've been given, if we pick an x value, we want to make sure that there's a point that goes along with that. So like, for example, if x is equal to 0, that's right here, this is where x is 0. Is there a point on the function? Right there, yes. So that means x equal to 0 is part of our group that we call the domain. If I say x equal to 1, is there a point? Yes, so that is in our domain. If I say x is equal to 20, well, that's going to be way out, further out that way. And since we know that this graph is going to keep going that way as well, then we can say, yes, it is part of the domain because there's going to be a point at that x value eventually. So we start to get this set of x values that we call the domain. If I say x equal to -2, what's happening at -2? There's a hole. Is there a point there that exists on the function? No point. So that means -2 is not a part of that domain. So when we write out our set, we're looking for which of the values are going to not exist. That's going to be basically how our set gets built. Because we see here, like this section here, obviously this keeps going to infinity. We know there's not going to be any more holes or asymptotes there. We've already found every single discontinuity. So discontinuity being a place where there's going to be a break in the graph or where the graph is not going to exist. So we've found them. It's this hole and this asymptote. So that means to the left here, there's not going to be any breaks. We know that's continuous. So we know all of that is in the domain. This part right here, we know that it's going to continue and it's never going to touch this x value, but it is going to touch every single other x value getting closer and closer to that. So we know that piece is continuous. And then after that asymptote, we know that this is going to keep going to infinity. So we have an x value all the way through. So our domain is going to consist of 3 different sections that are continuous sections, and they're going to be broken apart by the places where we have a discontinuity or a hole. So when I write it out, what I'll do is I'll start with -infinity. So we always start from the left side. And then we go to the first discontinuity that comes up as you're just following the graph. Break, it's at the hole. So it is at x value of -2. The y value, it means nothing to us really, because what we're looking for is there an x value? And so no, there is not an x value. So what I'm going to do is this interval is going to get cut off at -2, but I'm going to put open parentheses there. So what that means is for all values from -infinity all the way up to -2, but not including -2. So that means all of these little points like -2.000001, like even, further closer to that, is still going to be a part of our domain. Some people kind of have the instinct, and we can see why it could make sense. If we're saying -2 is not part of the domain, so then you can say from -infinity to -1, right? Because then you're like, okay, that's -1, stop there, not -2. But remember, we work with decimals, right? There's an infinite number of points between -1 and -2. We're not just working with those natural numbers, we're working with everything in between. So if I just said this to -1, we'll be missing out on this whole, or sorry, not -1, -3, right? Because some people might say, okay, well, we're going from -infinity to -3, and then we stop there. But we'll be missing out on this whole chunk that is also a part of the domain. So that's why we don't want to write it that way. We write it this way, including using that number that is not included in the domain, and we show that it's not included by this open parentheses there, as opposed to the bracket, which would be including that number. Then we union and look at the next part. So the next part, we're going to start with -2 with open parentheses, because again, we don't want to include -2, but that's where this next kind of piece is starting right after that hole. So we go from -2, and then the next discontinuity is this asymptote, which is at 1, 2, 3, x equal to 3. So again, similar notation, we put the 3 open parentheses because we don't want to include it, but we want everything leading up to 3. And then we got the last chunk here, is this piece that is getting picked up after 3 and is going all the way to infinity. Okay, so that is our whole domain, that whole thing that we see there. It's one thing I wanted to point out and it just escaped me. That's okay, it'll come back. Oh, but I do want to point out the different discontinuities that are going to help you to define this domain. So let's say if you didn't have the graph, if you hadn't graphed it out, but you wanted to figure out the domain and the range, all you need is the characteristics that we've already known how to find. So the hole and the asymptotes, those are the two main ones that are going to help you to find your domain and range. So for example, here, what did we use? First, we used the hole, which was the x value only. So when it comes to the domain, we only care about the x value of the hole. And then, where did 3 come from? It came from the vertical asymptote. So if you need to find the domain of a function, the 2 discontinuities that you will use are the x value of the hole and the vertical asymptote, which is already just an x value. Okay, horizontal asymptote, we see here, it doesn't make any difference when it comes to the domain. It doesn't affect those x values. Only the vertical asymptote does, because it makes it so that one whole x value just doesn't exist. Okay, so holes, x value, vertical asymptote is their domain. Sorry, I don't know why space out there. Okay, range. Actually, before we do range, let's do domain of this function so we can kind of see that the parallels there. So we said that we want to find the hole, the x value of the hole, and the vertical asymptote. Those are the 2 things that are going to affect the domain. So pretend we don't have the graph here, we're just going to look at this information and see if we can find the domain from this. So I have a hole and I have a vertical asymptote, and the x value of my hole is 5, and the vertical asymptote is -3. So when we write the domain, we always start with -infinity. And what that means is that the next value I need to use has to be in the correct order. So for this problem, the hole came first, but that's only because the hole was at -2 and the vertical asymptote was at 3. So -2 came first and then the 3 came afterwards. In this other example here, the hole is at 5 and the vertical asymptote is at -3. So actually, if we're going in chronological order, -3 will come first. We're going from left to right, from smallest to biggest. So even though that's the vertical asymptote, it's fine. It doesn't matter which one comes first, hole or vertical asymptote, as long as it's just in order. So we're going from -infinity to -3, -3, then to 5, and then 5 to infinity. Yeah, let me make this a little smaller so it'll all fit. Oops. There we go. Union 5 to infinity. And we can double check this. Like, let's look now at the graph and see that this all matches up the way that it should. So we start at -infinity, follow the graph, and we see that it's going to be continuous for that whole section up until it reaches -3. -3 is where we get the cutoff. So that's this piece right here. And then from -3 to 5, so -3 starts up there, and then it keeps going up to that hole. That hole again is where we're just cutting that continuous piece. So that's that section. And then last is 5 to infinity. That section there. We know that's going to be continuous. So that is how we find the domain. Please let me know if you have any questions. I'm checking the chat to see if anything comes in. So let me know, or just unmute yourself and ask. You can always do that. Let's do orange. All right, let's talk about range. So similar idea, except for we're looking at all of the y values. So I start from the bottom to the top because we're still going from left, sorry, not left to right, smallest to biggest. So the smallest values are at the bottom and then we go up. And so we're starting with -infinity, just like the domain, but that means we're starting down here. So same idea, I should be able to pick any y value and there should be a point that exists with that y value. So for example, here, y equal to 0, there's a point right there that goes along with it. So y equal to 0 is part of our range. Y equal to 3, there is a point right there. So that means it is part of our range. I can say y is equal to 50. It's going to be way up here. But I see that this graph is just going to keep going way, way, way up there. So that eventually there will be a point that crosses through 50. So 50 would be in our range. But if I say y is equal to 2, at 2, we have an asymptote, a horizontal asymptote. So we know that the graph is never going to cross that asymptote. So we know that it's never going to equal 2. So y equal to 2 is not in our range. If I say y is equal to 8/5, what is happening when y is equal to 8/5? There's a hole right there. And I know that because that's the y coordinate of my hole. So if there's a hole right at that specific point, that can't be in our range. So 8/5 is not going to be in the range. So the two things that are going to break up our range and not be included in the range is holes and horizontal asymptotes. So for the domain, it was vertical asymptotes. Range is horizontal asymptotes. And again, we're going from bottom to top, so smallest number to biggest number. I have a hole and I have a horizontal asymptote. The hole comes first. The hole is smaller at 8/5. And then we union 8/5 to 2, union to infinity. So that is our range there. And we can, again, just kind of go through the different sections. So we've got this section right here, that's -infinity to 8/5. And at 8/5 is the hole, so we can't include that as our range. But then we have this section here. This is going to keep going and going, but it's never going to touch y equal to 2. So that's that piece there. And then after y equal to 2, it jumps up to this piece, which just keeps going infinitely. So to infinity. Okay, so that is our range. Now let's do this example here without the graph. We're just going to look at the information that we have found to be able to determine that range. So we said we need to know the y coordinate of the hole and the horizontal asymptote. Slant or oblique asymptotes is a bit of a different story, and we'll kind of talk about that in the next problem, but we also really won't go through how to actually do it, just because that's not the biggest priority here. So we'll talk about that in the next problem. But we do have a horizontal asymptote in this case. It's at y equal to 0. So the two values are 1/8 and 0. So we're going to go from -infinity to 0, since that's the smaller of the two values. And then that's going to union to 0, 1/8. And then that's going to union to 1/8, infinity. And let's look at the graph and check that this is all looking good and working out. So this piece starting -infinity keeps going until we get to y equal to 0, that horizontal asymptote. So that checks out. And then right after that asymptote, we're picking up right on this side, because that's the side that's going to keep getting closer and closer to the asymptote. And that's going from 0 to 1/8. It doesn't get very high, right? It's just like that little piece. And then once it reaches 1/8, we have a hole. And then after that hole, it just keeps going up and up and up and up to positive infinity. And that is our range graphically, and then also just using analytics of the data that we have collected, right? Does the order matter? When you are writing out the domain and range, yes, it does matter, because basically what is happening, domain and range, if it's any regular function, it's going to go from -infinity to infinity, right? It's going to be continuous. Like if you have a parabola, it's continuous from -infinity to infinity. But then once you start putting in holes and asymptotes, you're breaking up that negative infinity to infinity section. So when you write it out, you want it to be in order from negative infinity and then going up to positive infinity. So it is in order. We see here -3 is smaller than 5. And then let's say maybe you had another whole and it had an x value of 7, then that would come after. You would put that in right in here. So you would put the 7 and then you would break that up and then you do 7 to infinity. So you can have as many of these sections as you need, but they should all be in order from smallest to biggest. Okay.
Wait, Miss Martin?
Yes.
I'm confused still on like how you found the middle like domain, like the -3 and 5, and then like the range, like the 0 and then 1, 8. Like,
So that little piece.
Yeah, like the middle one.
Okay. So for domain, it's gonna be, let me try and highlight this again. Negative infinity to -3 is this piece right here, because domain, we're talking about x values. So it's all of these x values, but it's getting cut off at -3. And then we see here the next discontinuity is at the whole. So between this vertical asymptote and this whole, it's from -3 to 5.
So the middle one is like from the vertical asymptote to like the whole then?
Mm-hmm.
Okay.
Yeah. Yeah. Or, I mean, the order, like in this case, it was from whole to vertical asymptote because the whole came first on the left side.
Okay.
So it's discontinuity to discontinuity.
Okay.
Is basically what it is.
Thank you.
You're welcome. So as long as you kind of follow that pattern, right? You start with negative infinity, and then you go discontinuity, 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 as many discontinuities you have, and then you end with infinity. So that's kind of the pattern that you want to follow. For the range, this 0 was the horizontal asymptote, and then the 1/8 was the whole. So discontinuities and then infinities on the ends. All right. Any other questions? Let me know. We're going to look at example B. Next here. Sorry, I'm going to see if I can submit my attendance really quickly. Don't think. Just missing tongue. Okay, I'll just let that load. Let's look at example B. Oh, wait, sorry. It loaded. Okay. Let's keep going. So we have now a function that has a slant asymptote. The slant asymptote is like the replacement of the horizontal asymptote, right? You have either or. So what that means is it's not going to affect your domain because the domain is only affected by a whole or a vertical asymptote. So domain is going to stay exactly the same here. I see that there is actually no holes in this graph. So I only have one discontinuity, which is this vertical asymptote at x equal to -3. So when I write the domain, I start with -infinity. The discontinuity is at -3. And then I'm going to union and go from -3 to infinity. So this one doesn't need that little extra middle part because there's no other discontinuity. So there's just one discontinuity breaking apart, -infinity to infinity. And that's it, that's our domain. For the range, it depends on the slant asymptote, kind of like where it's located and its slope. In this case, if we look at where it's at, we have this slant asymptote here. Remember that we're talking about the y values when we talk about range. So what we want to see is there a point for every single y value? And we don't have any holes here, so there's no holes. We just know that there's this slant here. So if I pick y equal to 0, just kind of randomly, this is y equal to 0. Notice how it actually crosses through at 2 places here. Y is equal to 0 at 2 places. So we know for sure y equal to 0 would be in our range because there's at least 1 point, but actually there's 2 points. Y equal to 5, there's a point that goes along with it. Y equal to 10, point that goes along with it. I could keep going higher. Because this function is going to keep going, there's always going to be a point that matches up with it. Same thing down here. I can say y equal to -50. I know that this is going to keep going. So eventually for -50, there is going to be a point that goes along with it. So is there ever going to be a place where there's not going to be any y value? The answer is no. Our range in this case is from -infinity to infinity. And that's because if you look at the slant asymptote, it's slanted enough so that each piece kind of overlaps. So if this is your slant, if I turn it into a horizontal asymptote, this whole section here, there's not going to be any graph that goes through it, right? But if I tilt it a little bit, then the graph will start to go a little bit higher infinitely forever. It might take a while because it's just a little bit of a slant. So it's going to take a while for it to reach any higher y value, but we know that it will because it's going to infinitely get higher and higher and higher. So the range in this case is -infinity to infinity. You can even think of it if you just block out, let's say for example, if I just block out the whole left side there, think about the piece that is left here. This piece is going to keep going down. So we know for sure it's going to go down to -infinity. This piece here is going to slowly keep going up, right? So that eventually, way out in infinity, it's going to keep going to infinity and keep. So even just this one section here covers -infinity to infinity. So that's it. Even if there was a hole over here, it doesn't matter because it's covered on the other side. So if one piece is continuous from -infinity to infinity, that means your whole function, the whole range of your whole function is going to be from -infinity to infinity. So I know sometimes that can be confusing the first time you see it. Let me know if you have any questions on it. We're going to see a kind of counter example where we have a slant asymptote, but that's not going to be the case for our range. And here it is. So if we look at this graph here, we see that the slant asymptote is really, really slanted. And not only that, but we see that the pieces, oh, I can change the color. Hold on, I just discovered something new. We're gonna play with it for a second. What does hold laser tail mean? Let's do it in blue. Oh, that's cool. Wait, how do I undo? Oh, very cool. Okay, that's fun. You learn something new every day. Right, so we're talking about what is the difference, right? When your range is going to be from negative infinity and when it's not. Notice the kind of quadrant that is made by these asymptotes, and notice where the graph fits in those quadrants. In this case, it's inside of the little kind of piece that is formed there. And in this case, it's on the kind of larger side, which is kind of hard to tell because it's not very slanted, so it's not that much kind of larger. But you can kind of see that if it's on this, in these two quadrants, this is going to keep following the graph and keep going up. However, over here, this piece is going to keep going down, and it's never going to go up to try and kind of catch up and meet with this piece, right? So if it was over here, then it would, wait, I'm going to try the, oh, this is a game changer. Let's see. See, if it was here, then it would keep going up and then the range would keep going to infinity. But since it's down here, it's always just going to go down from this particular point that we see there. So our range is cut up here. There's this whole section of y values that doesn't have any corresponding point to go with it. We don't necessarily have all the tools to figure out exactly what some of these points are. Like in this case, remember we had to do just like a little estimate of where this kind of vertex is at. So when it comes to these kinds of ranges that aren't just automatically negative infinity to infinity, I'm going to ask that you just kind of estimate. I won't give you a quiz question, or if I do, I'll say estimate. But I will try not to give you one where you feel really, really unsure about how to answer it, just because it's not the biggest situation trying to find that value. We can eyeball it and we can just guess and we'll move on, as long as we kind of get the gist of how to find that range. When you get to calculus, you learn, you get more tools like learning maximum and minimum, using calculus to make things quicker, because we technically can find maxes and mins right now, but it just takes too much time. So we don't want to worry about that. We want to kind of get through rational functions in general. So we're just going to estimate. So like in this case, let's see how we find the range of this. For the range, we start at negative infinity. Well, for both domain and range, we start at negative infinity. And then, so that's going to be here. And it's going to keep going up until this point right here. And then it's not going to go higher than that point until we pick up in the next section. So what I'll do is I'll try and just estimate what this point is for right now. It looks like maybe like -4. So I'm going to say from negative infinity to -4. Just a really rough estimate, okay? And then we're going to union that. And actually, sorry, -4 is where there actually is a point. is not a discontinuity at -4. It's a discontinuity right directly after -4. So actually what we want is a bracket in this case, because -4 from our assumption, from our estimate here, is actually a y value, right? Sort of, kind of. That's our estimate. So then everything after that is not going to be the case. So we do want to include it. And then the graph picks up at this point right here that has a y value of 0. So we're going to include it. So starting with 0. And then this is going to just keep going to positive infinity. And that is our range. So we see that there's this whole gap right in between -4 and 0 that is not accounted for in the range. And that's because we have this huge gap in the actual graph or the actual equation there. So I don't, oh, we didn't do the range here, or sorry, domain. The domain, we have a hole and we have a vertical asymptote. The x value is 1 and -3. So it's going to go from -infinity to -3 since that's a smaller number. Union -3 to 1, union 1 to infinity. And that is our domain, along with our range, which was an estimate because of that value there. All right. Any questions on that? Please let me know before I let you go and start reviewing things.
How come the brackets are closed for the range? Like the hard bracket, you know?
So the reason it's closed is because there is no actual discontinuity at these y values. There's actual points there. So there is a y value that corresponds to that, or a point that corresponds with those y values. It's all of the y values after that and in between that that doesn't exist.
Okay.
That makes sense. You know, when we're talking about the domain here, -3 is a discontinuity, so we can't include it. And same thing with 1, it's an actual discontinuity. There's no point there, but there is a point at -4 and there is a point at 0. Okay. Other questions?
How would you find those points, like when you're graphing the oblique asymptotes? Like, how would you find that point that you include when you're graphing?
In this case, I just eyeballed it, to be honest. I just kind of looked and was like, okay, it looks like the symmetry from like this center here to this point, because this was an actual 0. So I just kind of was like, okay, this go up 2 over 1, so down 2 over 1, that puts me right in this spot here. So it was really just like eyeballing estimate. You could just look to see, okay, -3 is where this asymptote is. So then you can actually try plugging in -4, because that would be the next number over. Plug it into the function. And then you can get an estimate that way. You could even try doing like negative, let's see, what is that? 3.001. I lost my graph. Right, if you want to get closer, you could do like plug that into the function, so then you can get an even closer kind of value to that. But yeah, like it was really just I eyeballed it.
Wait, so do you just like, why do you go up 2 over 1 from the where the asymptotes intersect?
So because this vertex of the piece. I know this point. We found this point because it's a 0.
Oh,
So we knew that point was the minimum of that top part. So I just tried to kind of mirror that across.
okay.
If that makes sense, just kind of mirror it on the other side, the same distance.
All right.
Cool. Any other questions? Okay, so there is a worksheet that's been posted. It should say review on it. Please go ahead and get started on that. There's actually we have like 5 minutes left of class time, so I'll stay on here, answer any questions that you have as you're like starting the review sheet or looking over your notes again. And then we have tutoring from 12:30 to 1:30. So if you have any other questions that kind of come up, I'll be here to answer them. So let me know if you have